Hey there, Mr. Weaver here, and this is topic 2 and 3, lesson 6, slope-intercept form from tables. After this lesson, you need to be able to write an equation in slope-intercept form from a table of values, and you need to be able to answer a question in context based on the information in the table. You'll know you're successful if after this lesson you can write an equation from a table and you can use the table and your equation to answer questions in context. When we're writing equations from tables, we have 3 basic steps. So step 1, you're going to identify the rate of change. So how much is it changing each time to go from one value to the next? Once we know that, we're going to create a rule using our slope-intercept form, y equals mx plus b, and we're going to plug in that rate of change. Finally, we have 2 options. We can substitute any ordered pair in the table for x and y and then solve for b to complete our equation, or we can follow our rate of change backwards using that same pattern until we find or figure out where x equals 0. So let's look at what this means and how to go through these steps. Here we have a word problem and a table that goes along with it. So the cost to make 1 to 4 bracelets is shown in the table below. Determine the rule for the cost of making any number of bracelets. If we look at our table, here we can see that if we make 1 bracelet, we're going to earn $7. 2 bracelets will earn $22. 3 bracelets would let us earn $37. 4 bracelets would make us $52. Okay, so our number of bracelets is what we put in. Our revenue is what we get out. First thing that we need to do is find our rate of change. So the rate of change, the easiest way to figure out is to think about if you had 1 more of your item, in this case bracelets, how much does the total change? So if I had 1 more bracelet, so instead of 1 I made 2, how much more money did we make? I went from 7 now to 22. My total went up by $15. So by going up 1 more bracelet, my total went up $15. My rate of change must be increasing by 15 each time. And I could confirm that if I went from 2 to 3, 22 to 37 is also plus 15. 3 to 4, 1 more, 37 to 52, also 15. My total is going up by 15 each time. So rate of change, 15. Now, to find our y-intercept, we're going to look at both ways that we could do it. Either way, we need to look at and figure out where do we start. So starting in this case would be, what if we sold 0? Well, 0 is not in our table. If it was there, we could just choose the number that's with it as our y, and that would be our y-intercept. But since it's not there, we need to figure it out. So I'm going to figure out what number is paired with 0. And I'm going to first do this by working backward. I know to go from 0 to 1, I just had to make 1 more bracelet, which would mean my total went up by $15 because it follows that same pattern. So if I went up by $15, where did we start? Well, we must have started at -8 because -8 plus $15 more would give us our 7. We can use this to work backwards to find values that would have occurred with negative values as well. -8 is our y-intercept. That's where we started. Now that we have those 2 things, we can plug them in our equation. So our equation for any number of bracelets would be y equals 15x minus 8. Let's look at the other way that we could have found our y-intercept, using substituting. So we know from the previous problem that our rate of change was 15. Once we know that, we can plug 15 in for our rate of change in the equation, and then we can solve for B. So I'm going to choose one ordered pair from my table. So let's say I choose 1, 7. If I make one bracelet, I earn $7. I'm going to plug those values in for X and Y. So 1 would go in where X is, and 7 would go in where Y is. Now I'm going to work to solve for B. So 7 would be equal to 15 plus B. I would subtract 15 from both sides, and I would be left with B equals -8. Both ways give us the same y-intercept, and therefore they give us the same equation. Let's look at the second example. The temperature of a liquid was measured every few hours as shown in the table below. At this rate, what will the temperature be after 34 hours? First, we need to find our equation. So we need to figure out our rate of change and our y-intercept. If we look at the table and just look at the y values, this time it goes down 6. But be careful, the time did not change by just 1 hour. It changed by 3 hours. So that's like it went down 1 hour 3 times. So that -6 is actually 3 movements of temperature. If we wanted to figure out how much it went down each hour, we would split it into 3 groups. So -2 each time. And so one of those movements must be how much it changed in 1 hour. We could have quickly figured this out by just dividing. It went down 6 degrees and it took 3 hours to get there. I would still get -2. So my rate of change is -2. Now I can use my rate of change to figure out where my y-intercept is. Again, that is when our x value, or here our time, is 0. I'm going to use the pattern method and work my way backward. Since I see that 1 hour was our first x value in the table, I don't have to work back very far to get to 0. In fact, I only have to go back one place. So if I had 19 and I worked my way back one place, so I took away that -2, it had to go down 2, I must have started at 21. Now that I know my rate of change and y-intercept, I'm going to plug them in and get y equals -2x plus 21. To get my answer to the question that it's asking, so what will the temperature be after 34 hours, I'm going to use that equation, and then hours is our time. That is our x value. So I need to plug in 34 for x. If I substitute in 34, now I can simplify it out. So y must have been equal to -47, and our units were degrees Fahrenheit. Now it's your turn. Pause the video and try to figure out the equations and answers to each of your tables. Check your answers. That's really all there is for tables. So, in this lesson, we created an equation from a table. To do this, we need 2 things, our rate of change and our y-intercept. Once we figure those out, we just plug them into our slope-intercept equation, and there we have it. To find the rate of change, we just figure out how much the output, your y value, changes every time you increase the x value by 1. In the table, you're going to want to look where your x value goes up by 1. If it's not, just note how many times that it goes up. Here, for example, we have a cost of a pizza for how many toppings we ordered. I chose the easy numbers, so I noticed that 12 to 13 went up by $1, but that meant after I added 2 more toppings. So 2 toppings was $1, which means each topping had to have been 50 cents. that is our rate of change. The cost is going up by 50 cents for each topping that we add. Once we know our rate of change, we can work to determine our y-intercept by working backwards to figure out how much it would be for 0 inputs, or we can substitute and solve for b. In our example, since we knew that each topping was 50 cents, if we took away that one topping, so we now have 0 toppings, we would take away 50 cents from our total. Our start value must have been $9. So our y-intercept was 9. Putting both of these into the equation, we would end up with y equals 50 cents x plus 9. Now that we know our equation, we could figure out the price of our pizza no matter how many toppings we put on. So if we wanted a pizza with 20 toppings, we could figure out the price. After this lesson, do you know how to write an equation in slope-intercept form from a table? And can you use a table and equation to answer the questions in context? If you're not sure about these things, go back and look at the examples and see if you can figure them out and help deepen your understanding. And that is the end of Lesson 6 on equations from tables.